Now we are looking for the general pattern or general form of arithmetic progression, how it looks like. We are going to consider this here. General form of arithmetic sequence. Before that, I am going to consider a new definition or a different definition in terms of common difference. In view of the common difference D of AP, we can rewrite the definition of AP as a sequence of numbers A1, A2, A3, etc. is said to be AP if AI minus 1 is equal to D for all I starting from 2 only, 2, 3, 4, etc. Now, we can see the general form of arithmetic progression. What is general form? Now we can see, let A1, A2, A3, A4, etc. be AP with common difference. Okay. In view of the definitions made above in terms of common difference, we fix A1 is equal to A, then we can say A2 minus A1 is equal to D. This implies A2 equal to A1 plus D, that is A plus D, and A3 minus A2 is equal to D again by the definition of the AP, and A3 equal to A2 plus D, and A2 which you have already found, that is A plus D, A plus D plus D, that is going to be A plus 2D, and similarly A4 minus A3 is equal to D implies A4 equal to A3 plus D, and that A3 which you have already found by method of difference, A plus 2D plus D, and that is going to be A plus 3D, and so on so forth. Thus, therefore, the general form of AP is A plus D, A plus 2D, A plus 3D, so on and so forth. This is the general form of a sequence, and so I can write down this as this is the general form of the sequence. Next week we are going to consider the nth term of the arithmetic progression. What is the nth term of the progression? We can see here. Let A1, A2, first let me write down the general form which we have obtained already now. A plus D, A plus 2D, A plus 3D, so on and so forth. That is we are going to find out the nth term here. Now this is T1, that is first term, second term, third term, and fourth term, and now this is nth term, which we are going to find out now here. How to find out? By using the general form of the arithmetic progression. Here A, I can write down this as A plus 0 into D. That will give A only. That I can write down here A plus 1 minus 1 into D. And similarly, we can write down A plus D can be written as T2 A plus 2 minus 1 into D. And this is A plus 3 minus 1 2D, which I can write down. And similarly, A plus 4 minus 1 into D. And one, we can easily guess the nth term, namely A plus n minus 1 into D, and so on and so forth. Thus, nth term Tn, or I can write down An is equal to A plus n minus 1 into D. This is the general term which you can write down. So, this is the nth term of the sequence. Here we are going to consider some examples here. That is, some examples I am going to consider the for AP, which are general form to be written. And now you can see examples I am considering here are: find the general form of a nth term of the following APs. One is root 2, root 8, root 18, and root 13, so on and so forth. And second one, 11, 8, 5, 2, etc. And third one is 3, 15, 27, 39, etc. Now the solution or answer, I am considering only one first example itself, that is root 2, root 8, root 18, root 32, etc., which can be written as root 2, 2 into root 2, 3 into root 2, and this is 4 into root 2, so on and so forth. This is the general form of the sequence which form AP, because it is common difference is 2 root 2 minus root 2 is equal to root 2 into 2 minus 1, that is root 2 only, and hence it is an AP. This is the general form of sequence. And one more example I would like to consider here. Third one, 3, 15, 27, 39, so on and so forth. First term is 3 here, and what is common difference? Common difference D is equal to 15 minus 3, that is 12. Since it is an AP, 27 minus 15 again at 12, and therefore general form of this is 3 plus 12, 3 plus 2 into 12, 3 plus 3 into 12, so on and so forth. This is the general form. Another set of examples I am going to consider. This is in the following. APs, arithmetic progressions. Arithmetic progression. Find the missing term in the boxes. 1, 26, second, 5, second term is missing, third term is missing, fourth term is 9.5. Third example, the first term itself is missing, second term is 38, and fourth is missing, fifth is missing, sixth is missing, and seventh, 1, 2, 3, 4, 5, sixth is given as minus 22. Now I am considering the solution of 3 only. Now we can see this term, that is 38 is equal to, I can consider x, and this is a box, this is a box where the term is missing, this is a box where term is missing, and the last term is a minus 22. And if you fix 38 as x, then the first term is going to be x minus d, x plus d, x plus 2d, and dx plus 3d, and minus 22 is going to be x plus 4d. And therefore we can see here x plus 4d is equal to minus 22, and if this implies 38 plus 4d is equal to minus 22. This implies 4d is equal to 4d is equal to minus 38 minus 22. Therefore 4d is equal to minus 60, and hence d is equal to minus 15, and therefore a1 x minus d is equal to, x is 38 minus d means minus 15, that is going to be plus, and therefore this is going to be 53. The first box, the first term is 53. Third term, x plus d is equal to 38 minus d, plus minus d means 15, that is going to be 23. 38 minus 15, 23, and x plus 2d is equal to 38 plus twice into minus 15, that is 38 minus 30 is equal to 8, and this is the third term. Fourth term I can write down, that is x plus 3d is equal to 38 plus 3 into minus 15, 38 minus 45 is equal to minus 7. The fourth box is a minus 7. Anyway, the last term is given here as minus 22. In this way, we can find the missing term in arithmetic progression by using common difference and the general form of sequence. In the next video, we are going to consider some of the first n terms of the sequences, arithmetic progression.